If ChatGPT has failed you twice, the third time is not the charm. And it's got nothing to do with whether it knows the answer. You've probably experienced this. You're deep into some chat trying to fix something, and then the agent takes a swing and a miss. You correct it by yapping a bit. It swings again, misses again. By the third attempt, you're getting these confident, slightly deranged answers that are measurably worse than where you started. Then you open a fresh chat, paste the exact same problem in, and it nails it one shot. What you experienced has a name. It's been measured. And there's a paper from May that found that the fix everybody's been using since 2023 has the same bullshit baked in. This realization changed how I build. So let's get into it. Two forces act on every token LLMs produce. The first force is instructional force. This includes your system prompt, your rules the agent remembers, the cosplay, you're a senior engineer with 20 years of experience, make no mistakes type shit. It's everything that you are explicit about how it needs to behave and what it needs to do. The second force is one I like to call the inertial force. This is the force that comes from whatever is already in your context window, or the chat history. All the agent's tool calls, failed attempts, wrong turns, and the whole ugly transcript piled up behind your current message. These two forces compete. When they disagree, inertia wins way more often than anybody wants to admit. I heard someone on Reddit say, if it's failing, it's conditioned to fail again. If it's winning, it's conditioned to win. Source, trust me, bro. No, but seriously, why? Your model can't tell the difference between an example that you gave it on purpose and something that merely happened in the chat. You might know few-shot prompting. You paste in 2 or 3 examples of the thing that you want, and the model then generalizes that behavior over new situations. This is in-context learning, and it's most of the reason prompting even works in the first place. But there's no labeled section anywhere called examples that it reads differently. It's just reading a sequence, and everything in that sequence, including the 6 times that it just failed, is a demonstration of what happens here. So when you try to correct it and it fails again, you're no longer correcting it, you're giving it a few-shot example on how to fail correctly. That's why parents who lead with, "do as I say and not as I do," are always surprised when their kids fuck up in life. It's like a masterclass in how to be a loser. Sources for this video are in the pinned comment. Be sure to like and subscribe so I can keep bringing you the hits. In 2022, the GPT-3 era, a paper called Rethinking the Role of Demonstrations demonstrated that. They took few-shot examples and replaced the answers with random labels. They swapped in the wrong answers on purpose. Guess what? The performance didn't even dip much. They tried it on 12 models, got the same results, and learned that what actually drove the results was label space, the input distribution, and the format of the sequence. So what the model learns is more like the shape of the exchange, and it could actually give a shit about whether the answers were good or not. In a debugging session, the shape it learns is user complains, agent edits code. And the part where the last 3 edits were wrong barely even registers. Let's take this as an example a little bit closer to the heart. You might have lived this one. You tell the agent to commit the code after it performs edits. Once. And now the damn thing commits after every single edit unless you tell it to stop committing. The agent gets into a commit frenzy because its own transcript shows commit after edit 3 times running. And that reinforces or adds another shot to your examples better than anything you actually say in your prompt. It gets worse. This can also lead to a loss of time and money. You get into a normal flow of plan, implement, test. You then go to test it yourself after a couple of rounds, and you find something is broken. But you can't quite put your finger on what. You actually have to go and look, or make it look for you. What you want in this moment is for the agent to stop, step back, investigate, form a hypothesis, and then come back and tell you what it thinks before proceeding to edit code. What actually happens, though, is the damn thing immediately edits code based on a half-baked idea of the root cause. Why? Because the pattern in context is already user says something, agent writes code for the last 3 turns. So it just writes the code without checking back because that's what inertia dictates. But then it tests again and its fix didn't work. Instead of stopping, it fucking goes apeshit and starts down a doom spiral that could end up in your entire codebase being deleted. 2 hours later, after you get it to stop trying to build Linux, you're reverting commits, trying to get back to the point where you only had the first problem. This effect was also given a name in the 2023 paper, How Language Model Hallucinations Can Snowball. A model overcommits to an early mistake and then just keeps making more mistakes it wouldn't have made in the first place. The real fucked up part, though, is what happened when those researchers pulled the errors out of that conversation context and asked about them raw. ChatGPT caught 67% of its own mistakes, while GPT-4 caught 87%. The damn thing knows. Lift the bad examples out of the chat, and it can see just fine. But it can't see past the mistakes if they're sitting there in the chat transcript. What's more is that failure isn't even required. In a paper from July 2025, Chroma ran 18 frontier models, and every one degraded as input length grew, some by 30 to 50%. None of them, by the way, were even close to the limits that the model makers advertised. It wasn't a retrieval problem this time, it was just length. These models done got caught in what I like to call the dumb zone. So what do? You type, "No, that's wrong. Think harder." And what do you get? More drool and slop. There's a paper on that one too. It's called Large Language Models Cannot Self-Correct Reasoning Yet. Without outside feedback, a model that revises its own answers can't improve, and sometimes does the opposite. You're trying to lean on instructional force, while the inertial force is clearly dominating here. All right, so back to my promise from earlier. There was a paper in March 2023 called Reflexion with an X. Reflexión, as the Spanish would say. It proposed the fix that pretty much all the modern harnesses use in some form. When the agent fails, it writes itself a short note about why, and injects that note in the context, replacing the actual train wreck. It compresses the crash into a lesson. I've built versions of this myself. I mean, it should work, right? Fast forward to May of this year. 3 researchers checked whether the note itself is any good. Spoiler, it's not. The paper is called Honest Lying. Agents write down confident, wrong interpretations of why they failed, and then act on those interpretations from then on. They keep this false belief even after the environment resets and hands them the correct task newly. It went from being inertia to flat-out trauma. In one frozen test setup where the agent wrote about its own failures, it failed to ever mention the correct target object. It went 0 for 121. More than enough reason to get benched the rest of the season. Now, obviously, the model wrote that summary while it was already sick. Their fix is the whole reason I wanted to make this video. They stopped letting it diagnose itself. They pulled the failure signals out programmatically with code that's not getting spawn camped, and that brought its score up from 0 to 86%. Then in June, another group found the same shape in a completely different spot. They broke down why models fuck up instruction hierarchy. That's the rule that states your system prompt is supposed to outrank everything else. And they found 3 failure modes. It's the third one that makes me want to puke. The model was resolving the conflict correctly in its reasoning and working out that your instruction should win, but then it emits the violating output anyway. They decided to fix that by using an external monitor, which cut violations 81 to 99%. Are you noticing a pattern here? Every intervention that truly works lives outside the model. Really, isn't that the whole reason for interventions? Okay, take all that, and now let's throw another spanner in the works. This is the reason you can't just take off and nuke the entire site from orbit, even though it's the only way to be sure. Most of the time, going with inertia is the right thing to do. It's the whole reason why long chats don't degrade into nonsense. Usually, you want it to keep doing the thing you've been doing in that chat, until you don't. You want the pattern to hold, so you can grind the same task all day like it's World of Warcraft. The problem is that the model has no idea which mode it's supposed to be in. Coding and debugging look nearly identical if you squint your eyes, but they demand completely opposite behavior when it comes to those nuanced cases where the root cause of a bug isn't glaringly obvious. This all caused me to build a system prompt, or a skill, where my agent has an explicit modality system so that it knows the legal transitions between modes. I literally put a mermaid state diagram in the prompt to explain how it needs to behave in each state, plus how to know when to transition from one to the other. I used the overpowered system prompt privilege instead of trying to explicitly type every message to remember how to act, and it worked. The cool part is that it helped me with context switching because I stopped having to track where things left off in every chat. If you think about it, and probably squint a little, we, low-key, have both of these forces too. I wash dishes one at a time at home. Don't ask me why. If you force me to batch them, you've put me in a spot because I don't know what the outcome looks like anymore, and that stresses me out. I'm just a simple lad who likes simple processes. You can snowball effect me right into noping out on the dishes from the sheer irritation of having to break my known pattern for something unknown. No matter how right you are, the model gets all that inertia and none of the irritation. So it just quietly keeps doing the old thing while acting like it's doing the new one. I suppose I do that too now that I think about it. The crazy thing about all of this is that this whole class of force goes unmeasured. It's not in the weights or any benchmark. It's semantic, like the shape of what already got said. And it's strong enough to beat explicit instructions from the person paying for the tokens, most of the time, which makes it unpredictable. My take after over a year of building harnesses is that models are slowly getting better at the nuance around picking instructions over inertia, but that's a lived experience more than a benchmark. Maybe that's the next experiment to run. Do small local models have it worse than me doing the dishes? How much dumber can I make them get just by doing some context editing? Anyway, I'll save that for another day, because for now, I'm gonna go touch grass.